Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of the Algebra 1 Common Core Regents exam for August 2015. Okay, let's take a look at problem 6. It reads, which graph represents the solution of y less than or equal to x plus 3 and y greater than or equal to negative 2x minus 2? Now, if you closely examine the options that we have, which is a good practice when taking multiple choice exams, you notice that the lines are identical. Okay, the only difference in the four options we have is the direction of the shading. So this question is basically assessing our ability to correctly shade a system of linear inequalities. Okay, so that is what our primary focus will be on in determining the answer. So before we start, a real quick point to recall, whenever you have a less than or equal to inequality, you shade in the downward direction. Whenever you have, if you have greater than or equal to linear inequality, you shade in the upward direction. Okay, so let's keep these points in mind. Now, let's take a look at the first equation. So we're gonna look at y less than, this is a less than one, so let's put it in blue. So we have y less than or equal to x plus 3. Okay, so this line has a less than, which means we're going to be shading where? Less than means you shade downwards. But how do we determine the line to focus on? We look at the y-intercept. Okay, so b is positive 3. So the line with the y-intercept of positive 3, the direction of the shading should be downwards. Okay, so option 1, this is the line with the y-intercept of positive 3. The direction of the shading should be downwards. Is that what's shaded here? The answer is no, so we eliminate option number 1. Number 2, this is the same line with the y-intercept of positive 3. The direction of the shading should be downwards. That's the case here, so we keep this for consideration later. Option 3, y-intercept of positive 3. Direction of shading downwards, that's good also. Option 4, the line with the y-intercept of positive 3. Direction of shading should be downwards for less than, but it is shaded above that line here, so option 4 should be eliminated also. Okay, so by focusing on the first equation, we're able to narrow down our choices to 2. Okay, so the second equation will help us determine the correct answer. The second equation is y greater than or equal to negative 2x minus 2. So since we have greater than, we're going to shade where? We shade upwards. We're going to shade upwards above the line with the y-intercept of negative 2. Okay? Remember your y equals mx plus b equation. The y-intercept is the b component as we did in the first inequality. All right? So the second line in each graph is the one with negative 2 y-intercept, as you can clearly see here, 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 here. Focusing just on option 2 and 3, we're looking for the one where the direction of the shading of the line with the y-intercept of negative 2 is upwards. Okay? So if you look at this line right here, the direction of the shading should be upwards. But is that what is shaded here? The answer is no. We eliminate option 2. Look at option 3. Direction of the shading for the line with the y-intercept of negative 2 is upward here. Perfect. This is exactly what we want. Okay, another way to do this problem, if you don't like to shade, is by picking a point that lies clearly in the intersection of the shaded regions and verifying if that point satisfies both linear inequalities. So you can pick a point here, Determine the coordinates, plug it in, see if it satisfies this. Pick a point here, pick a point here, and pick a point there. So if you test them in this system of linear inequalities, the point that works for both, that will be your answer. So that's another way of doing it. Final way of doing it is just by graphing these two and applying the shades, and then that gives you your final result. Okay, so there are different ways you can solve this problem. All right, let's take a look at problem 7. Problem 7 reads, the country of Benin in West Africa has a population of 9.05 million people. The population is growing at a rate of 3.1% each year. Which function can be used to find the population 7 years from now? This is another problem that it's really helpful to closely examine the options and basically look for patterns that can help you quickly answer the question. All right, so if you notice in this problem right here, all the options have an identical 9.05 times 10 to the 6 or 9 million. They have an identical exponent and an identical 1. The only thing that is different is this piece right here, the sign and that decimal number. Okay, so that's what we're going to be focusing on in this problem. So first thing we're going to do is we're going to write down the correct formula for this situation. Okay, this is a discrete population growth. How do we know that? It says each. Each means it's not continuous, it's discrete. So the formula for discrete growth is A equals, or let's use a system that's a format that's consistent with our options. We're going to use F, okay? So let's say F of t equals the initial amount, initial population. We can call it P0 or A0. Let's just call it A, initial population, times 1 plus the rate R raised to the t. Okay, so that's the formula we're going to be using here. Now, how do we know that it is a growth situation? If you read the problem, it says the population is growing. Okay, so one thing about growth formula is that the sign here is plus. Okay, that indicates growth. If it were a decay situation, guess what? This sign will be a minus. Okay, so this fact alone can help us narrow down the options. Which of them is the rate being added to the 1? Options 2 and 3, so we eliminate 1 and 4. Now let's shift our attention to this piece right here. What is that? That is the growth rate. Okay, now one thing you want to note is that R is the growth rate in percent. Okay, growth rate in percent. What does percent mean? Percent means per 100. Okay, so 3.1% is not in decimal form. How do we convert this to decimal form? Remember, 100 has how many zeros? 100 has 2 zeros. So if you want to convert percentage to decimal, you have to divide by 100 or move the decimal point forward 1, 2, twice, 2 places to the left. Okay, so 3.1%, we just have to move the decimal point 1, 2, 2 places to the right, and then you fill in a 0 in front. So 3.1% is the same thing as 0.031. Okay, so this is the correct R value that we need. This is the R value that we're going to be using. So which of the two options has the rate of 0.031 in decimal form? Answer is option number 3. All right, let's take a look at problem 8. It reads, a typical cell phone plan has a fixed base fee that includes a certain amount of data and an overage charge for data used beyond the plan. A cell phone plan charges a base fee of $62 and an overage charge of $30 per gigabyte of data that exceed 2 gigabytes. If C represents the cost and G represents the total number of gigabytes of data, which equation could represent this plan when more than 2 gigabytes are used? So this is a kind of problem that requires close reading. You have to really understand what's going on in order to generate the correct equation. Okay, so C represents the cost, so we start with C. Now, first thing we want to determine is the base charge. Base charge is independent of overages, okay? So here we're told that the base charge is 62. That's the base charge. So we start with 62. Now we're going to add on other things. $30 per gigabyte of data that exceeds 2 gigabytes. So if you think about per, you're basically multiplying. So we're going to be multiplying 30 by the number of gigabytes that exceeds 2. Okay, so let's say you have 5. By how many gigabytes does 5 exceed 2? 5 minus 2 by 3, right? And we have 6. By how many gigabytes does 6 exceed 2? You subtract, okay? Which is 4. Now what if you have G? By how many gigabytes does G exceed 2? Just simply subtract, okay? So that's what we're going to put in for the costs per the overage charge per gigabyte that exceeds 2 gigabytes. So we're going to have G minus 2, okay? So our answer for number 8, let's see, option 4. All right, let's take a look at number 9. Number 9 reads, 4 expressions are shown below. Okay, and we have these 4 expressions here. Question, the expression 4x squared minus 4x minus 120 is equivalent to, so which one of these? Now, the best way to, or the safest way to approach this problem is to see if you can simplify these options to arrive at this target expression here. Okay, don't try and go backwards because some of the factorization methods that I use here are not common. Okay, but expanding them is an easy way to really determine if they are equal to this expression. So I'm going to work forward, not backwards. All right, let's start with option 1. Option 1 is a simple distribution of the 2 to all the terms in the parentheses. Okay, so if we distribute that, option 1 is 4x squared minus 4x minus 2 times 60, 120. Is that good or bad? That is perfect. That's exactly what we want because it matches this expression right here. Option number 2. Distribute the 4 to all 3 terms in the parentheses as we did in option 1. If we do that, we're going to get 4x squared minus 4 times x is 4x. 4 times negative 30 is negative 120. Is that correct? It certainly is. Okay, so the answers with option 1 and 2 looks like where we're going. So if you look at the options you have here, one thing you'll notice is that options 2 and 4 do not include 1. So what do? We can simply eliminate those 2. Okay? The only one that includes 1 and 2 options 1 and 3. Okay? And if you look at option 3, it says 1, 2, and 4. So if we want to work smart, we can just jump to 4 and check it. If 4 doesn't work, our answer is option 1. If 4 works, our answer is option 3. Okay, so it's just a way of using the options to be smart in our work so we don't waste time. Okay, so let's go ahead and distribute the 4x to these 2 terms. What does that yield? That gives us 4x squared minus 4x minus 120. So option 4 is also equivalent to this expression. So we can clearly see that our answer is option number 3. Okay, if we test this one, we'll see that it's not going to yield the correct expression because we see there's no option there that has 1 and 2 and 3 included. All right, okay, let's go ahead. All right, let's take a look at problem number 10. It said last week a candle store received $355.60 for selling 20 candles. Small candles sell for $10.98. Large candles sell for $27.98. How many large candles did the store sell? Okay, so this is a system of equations problem. So I'm going to basically proceed to solve this problem in the fastest way to get our result. Okay, there are many ways that you can solve this, but the fastest way that involves fewer steps creates less room for error. Okay, so before I set up my system, I'd like to declare my variables. So let's call let S be number of small candles. Okay, number of small candles sold. And let's call L the number of large candles sold. All right, so let's put a let here. All right, now remember we're looking for L. L, the number of large candles sold, so that will be our focus. Let's go ahead and set up our equation. There are two equations we're going to have. We're going to have the cost equation and quantity equation. So let me start with my cost equation first. So selling cost. So remember we talked about this in the first installment of this review series, that we multiply the unit price times the quantity. That basically gives you the total price, okay? So, or total cost. So in this case, for small candles, they sell for $10.98 each, and you sold a total of S. So the price for small candles is going to be the unit price times the quantity, okay? So the unit price for small candles is $10.98. Let's change the color there. $10.98 times the quantity, which is S, okay? Plus, what is the total cost for the large candles? The unit price for large candles is $27.98, so that's the unit price. Unit price times the quantity. How many large candles were sold? L large candles were sold. Okay, so the total cost for the sales is $200. $355.60. So that's the total price for the sales. Okay. Now let's go into the quantity equation. Quantity is pretty straightforward. The total number of small candles sold plus the total number of large candles sold, L, is equal to the total number of candles sold, which is 20. Okay? So there goes our system of equations, just using the cost formula, unit price times quantity, and the quantity formula. All right, so now let's zero in on what we're solving for. We want to solve for L. If we're solving for L, that means we need to eliminate S. So how do we go about eliminating S? We want the coefficients of S in both equations to be opposites of one another. Okay? So this is 1098. If I can make this negative 1098, then I will be able to eliminate S by combination. Okay? So to make that happen, what do? I multiply the entire quantity equation by negative 1098. Okay? So if I do that, let's see what happens. If I carry out that multiplication, I'm going to rewrite the cost equation. 1098S plus 2798L equals 355.6. And then the second one, if you need to remember to distribute this 1098 to all three terms. Okay, so that gives us negative 1098 S minus 1098 L equals, if you multiply 1098 by 20, you get 219, actually negative 219.6. You can do that with your calculator, okay? Now, combine downwards, what happens? We eliminate s and we're left with the variable that we want to end up with. Okay, so these two add up to 0, and then when you combine these two, you can clearly see you have 7.00L, and then when you combine these two, you can subtract it with your calculator. You end up with 136.0. Okay, to finish this off, you just simply divide both sides by 7, so that we can get the total number of large candles sold. Okay, so if you carry out the division, you end up with L equals 7 goes, actually this is not 7, this is 17. Yeah, 17. All right, so that means you're going to divide both sides by 17, and then when you divide that in your calculator, you end up with 8. So that's the total number of large candles sold. Final answer for number 10 is option number 2. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found this tutorial helpful to you, please give us a thumbs up and share it with your friends. We'll appreciate that. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about the math section of the New York Regents exam, just include your question in the comment section below, and we'll be glad to assist you at our earliest convenience. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.